All right, hope you have a great lunch break. We're going to start our afternoon session. Many of us were talking that this is our first academic gathering after the pandemic, and we should do this again pretty much every year, and many of us really enjoy this occasion. Thank you, Ted, and we're just delighted to be here today. All right, and Josh, it's all yours.
All right. Thanks. I want to thank Wanjen and Yair and Bill and everybody else who organized this. It's a pleasure to do this. And it's been a little bit of a trip down memory lane for me, thinking back about the good old days. So I worked with Ted from around 1995 to 2003. I was introduced to him when I was an undergrad by Nancy Canwisher. And I think I came over and met with him my sophomore year of college. And we started doing stuff together. And the main people who were in the lab at the time were Yair, Hani, David Summers, who's here, Josh Tenenbaum, who didn't work with Ted himself, but was kind of around a lot. And then I went away for a couple years and came back and hung out a lot with Roland and Wanjen and Lavanya. And so I was able to recover one artifact from the era. Yeah. So prior to ARVO, I think it was 1998, Ted made us all T-shirts that were printed with one of his brightness illusions. So he was working on that at the time. And so you can see that the different rows of the shirt appear to be either light or dark, and they're labeled as such. But in classic Ted style, you can tell that it's an illusion because it's just the same cloth, right? So we all sported this around ARVO, and we're very proud. So I kind of think of that era as the heyday of what people used to call mid-level vision. So the Cambridge vision community in the late 1990s was pretty happening. So Ted and Bart Anderson were here. Ken Nakayama and Patrick Kavanagh were at Harvard, and there were just a lot of smart people doing creative and interesting things, and that was sort of the era where I really got imprinted. And for me, the highlight of that period was the Toiber Symposium, which probably a handful of you remember. This was a workshop that Ted organized, I think it was 1996. It was over in E25, and everybody who was anybody in that area was there, and it was just one of those moments that was really inspiring as a young person to just see all these really great, interesting talks. So my work with Ted at the time concerned interactions between motion and form. So everybody knows that vision is really shaped by occlusion. So the world is made of surfaces, and we see the world in terms of surfaces. And so things are always in front of other things. And so the visual system does all this stuff to try to recover that structure. And so, for instance, here, there's this gray rectangle. It's extending behind the ovals, and there's a sense in which you kind of know that those things are all connected, and that's often referred to as amodal completion. And so, at the time, there was lots of growing evidence that motion perception was very much influenced by all of those kinds of things. And so this kind of, was in the aftermath of the view from the 80s and early 90s that the visual system was very modularized and motion was kind of separate from all this stuff. But there were a lot of interesting demonstrations that was not entirely the case. And so Ted introduced me to some of this stuff, and I got pretty into it. So this is an old Flash demo that still works, but it doesn't work in web browsers, and so you have to play it in Flash Player. And so there's some moving lines here, okay? And so when you look at it like this, it kind of just looks like these two pairs of moving lines. But then if you introduce evidence that there is occlusion happening, the motion that you see really is transformed, and you see like this single thing that's kind of moving around in a circle. All right, so they're really amazing and incredibly rich phenomena. This particular version, I think, was introduced by Maggie Schifrar, and there's a lot of other things that are kind of like it. And so I got interested in how all this stuff worked, and did a bunch of experiments trying to investigate this, and among other things, found evidence that motion integration really interacts with these processes of amodal completion. So this was actually for my undergrad thesis. So I think because MIT doesn't do undergrad theses, I think I'm the only person who has had an undergrad thesis advised by Ted. So that's my claim to fame. This was one of the experiments from it. And so you can vary kind of the width of the occluding surfaces, and you don't max out the probability that you see a single thing until there's kind of room to kind of cover it with all these occluding surfaces. And you can change the aspect ratio, and then the point at which that happens changes in the way that you would expect. So we had lots of fun doing stuff like that. And so eventually I got bored with vision and transitioned into working in Audition. And I've been a professor here since 2013 working on that kind of stuff. But there's lots of conceptual parallels to all of the things that I learned from TED, and I'm not always kind of conscious of them at the time when we do the work, but it was fun thinking about this talk and looking back on all the things that I've done, and I can see all of these places where his influence shows up. But the problems are nonetheless kind of different. There's different ecological constraints, and I'll just briefly kind of tell you about one such example. So vision is really shaped by occlusion because objects are usually opaque, okay? And so the Gestalt psychologist talked about modal completion, shown here, where you have illusory contours. That's where a surface is in front of other stuff, and amodal completion, where something is behind other stuff. And audition, by contrast, is really shaped by masking. So sounds are transparent, and they add in the air, right? So everything just kind of superimposes. And so masking, although people study masking in vision sometimes, but it's mostly an experimental method. It doesn't happen so much in real life, whereas it's everywhere in hearing. So this is just one example from the cocktail party problem, if I can get my mouse back. So this is a person talking. You might want to try to understand. And what's shown next to that icon is a representation of what we think is the output of the cochlea. Right? So it's a time-frequency decomposition. So it's all this structure. And then the subsequent panels are showing what happens when more and more people get added to the cocktail party, and things get denser, but you can still often hear the person you're trying to hear. But what I've done here on the right is color-coded the pixels. And so the ones that are color-coded green are places where the target talker had a fair bit of energy, but where the other talkers in the scene have more energy, right? So they mask the target talker. Okay, so there's lots of green, right? That's the point. Okay, so it's been known since the 70s that the auditory system fills in sounds in some instances when there's evidence of masking. And so, for instance, like you can have a tone that has a little gap in it, and if you fill that gap with noise, and if the noise is high enough in intensity and in the right frequency range, you'll hear the tone as being continuous. And the same thing happens with speech. That's what's known as phonemic restoration. But these effects typically happen on really short time scales. So one of the things that I was exposed to a lot when working with TED was texture. And when I decided I wanted to work on Audition, I really wanted to study texture and sound. And so as a postdoc, I went and worked with Adelson and Shelley, who had done a lot of important work on visual texture, and we built a model of sound texture. And so I've been dabbling in that ever since. And we discovered by accident that textures can also be filled in to a very powerful extent. Right? So textures are ubiquitous in the world, and they're often kind of like the background noise in auditory scenes. So here's an example where you got a waveform of speech and of applause, and they superimpose. And in this cochlear representation, all the places where the speech kind of overpowers the background texture are colored red, right? So there's a lot of red, okay? And so we found out that people have like a remarkable ability to kind of fill in this sort of missing texture that's when it's plausibly masked. And so I'll play you a demo of this. And this is, again, one of the things I learned from TED is the power of a good demo. So we make a lot of demos in sound. One of the frustrating things is that you're often playing demos in rooms like this, where there's lots of reverberation and you don't have a whole lot of control over what goes into people's ears. So I hope these work. They're pretty good. So I'm going to play this sound where there's 2 seconds of a texture of applause, and then 2 seconds of noise that's like pretty high in intensity, followed by some more applause. And you'll probably have the subjective experience that applause continues during the noise. All right, let's check it out. Yeah, all right, so it sounds like it's there, and you may not believe me, right? So lest you think that I made a mistake and the applause is actually there, or this is the power of suggestion, here's another version where there's a little gap between the texture and the noise, and this should kill that illusion. All right, so there it just sounds like noise, okay? All right, so this is interesting for a bunch of reasons. Like one, it provides pretty compelling evidence that you're actually representing textures with statistics, because that's really the only thing that you could be filling in there, okay? But also the fact that it lasts so long kind of really makes it clear that you actually hear the thing, right? So it raises this question of like, well, what's going on in your head? Is that filled-in sound really represented like actual sound? And so we did some experiments to try to assess this, and we leveraged the fact that because you represent textures with statistics, those statistics kind of have to be aggregated over some period of time, all right? And it turns out that's usually a couple seconds, all right? So here's the experimental paradigm. So it's a discrimination experiment. We establish a direction in the space of statistics that's defined by like an average texture and then a reference texture, okay? And we're using these synthesis methods that Arrow and I worked on 10 years ago to make these stimuli. So there's this one sound here that's in blue, that's schematized here by this trajectory through the space of statistics, and it undergoes a change, all right? And people have to make a judgment about the endpoint of the blue thing, okay? And they're doing that by comparing it to the black thing, this morph, all right? And so the judgment here is you listen to these things, and you have to say which of these is more similar to the reference, all right? And so the idea is that you're going to be biased by the stimulus, the recent stimulus history, because you're kind of averaging things over time, okay? And so in a situation like this, where there's this change in the stimulus that's in the recent history, you should be biased. But in a situation like this, where the change is like further back, you won't be biased. And that's in fact what you see, okay? So these are psychometric functions for situations where the stimulus history is in one direction, that's in blue, or in another direction, that's in red, right? And you get this bias in the perceptual judgments, which indicates that people have integrated the stimulus history in this way. But if you move that change further back in time, that bias goes away, all right? So there's like an integration window of like a couple seconds. Okay, so that's the setup here. So the interesting question here is like, what happens if we actually have people experience this illusory texture, all right? So we put noise here, and we know that people subjectively hear this thing, and the question is that illusory sound gonna bias what they actually end up attributing to the texture here, okay? And the remarkable result is that it does. So you put noise here, and the texture that preceded the noise biases people's judgments of the thing at the end, even though there's nothing there in the noise, okay? And if we put that little gap before the noise, that kills the effect, all right? So it seems like your auditory system is really like reconstituting this representation of this inferred texture, all right? Okay, so the filling in, it occurs under conditions of masking, as you would expect. So if you actually measure people's ability to detect a texture superimposed on noise, so you can measure detection, that's the orange curve as a function of signal-to-noise ratio. So when the signal-to-noise ratio is low, you can't detect the texture. But then if you measure these judgments of continuity, you find that people hear the continuity in cases where they can't detect the texture, right? So you fill in the sound when it would have been masked. All right, and that's kind of consistent with the way people have thought about this stuff. Okay, so just to wrap up, masking is sort of like occlusion. All right, so when a sound is masked in hearing, it's locally undetectable, right, as is an occluded object. But unlike occluded objects, for which you experience amodal completion, you actually hear the masked sounds when they're filled in, right? And we have evidence that they're treated by your brain as though they're like an actual sound that is present, okay? So it sounds just like it would if the masker were actually absent. And so the perceptual code that you experience when you listen to this thing is really more akin to what people call modal completion, like an illusory contour. And so I think like the kind of interesting observation here is that vision really has to differentiate two scenarios, all right? One of them is occlusion, where something is behind another object, right? It's not visible, right? And so you represent that with a modal completion. You sort of know that it's there, it's represented in some sense, but you don't actually see it. And then there's camouflage, right? Where an object is in front, and again, there's not local evidence for the presence of the object, but you fill that in and you actually subjectively experience it, right? So you have these two different perceptual codes, whereas audition just has masking. And so in these cases where sound is not detectable, but you kind of infer it's present, you actually hear the thing, all right? So this is just one example of where these ideas that I first experienced working with TED kind of have reverberated into my auditory work. Thank you, TED.
Thank you. Any questions? Okay, well, we have quite a few.
Fascinating talk. Have you played with spatialized sounds, and do you think you could get an occlusion type of effect if you've got sounds from this direction?
Yeah, probably. I mean, in other domains, stuff like that kind of happens. I suspect there would be some effect, but I haven't tried it in this case. Yeah.
So, since you said you have perception of nerves that show that you're actually think the creation of it happens?
Yeah, so the question is, given that we have evidence that there's, in some sense, like a real actual representation of this filled in sound, does that mean that it happens early in the auditory system? We don't know. That seems plausible. Those experiments remain to be done. Yeah.
A couple of questions. One is gap between the sound and the mask affects what you hear. But what about the width of the mask? How does?
Well, what happens typically, and we've measured this, is you hear this illusory sound for a while during the noise. If the noise just goes on and on and on, eventually it kind of fades out. But it lasts 2, 3, 4 seconds, depending on what the texture is.
The other is, you mentioned about occlusion can almost like front accent, where the mask sound come first, and then the signal comes.
Yeah, so there's a little bit of retrospective filling in that happens. It's pretty brief. It's like, fractions of a second. So yeah, it works a little bit in the other direction.
Okay, maybe one last question.
Yeah.
Yeah, I mean, it's a bit like that.
Spatial rather than a temporal gap.
Yeah, and there is sort of, it's been a while since I looked at that stuff, but I believe there is evidence that that is kind of statistical in nature. Like you can kind of fill in like the appearance of text and stuff like that, I think. Yeah, yeah, no, that's a good point. Yeah.
Well, let's thank Josh again. Our next speaker will be Henny.